In this video, you will learn how to expand binomial expressions raised to a certain power, by using binomial theorem in Pascal's triangle. Let's say our binomial expression is denoted as a plus b to the power of n. Okay, a here is the first term of our binomial expression and b is the second term, and n is the power or exponent to which the binomial expression is raised to. So how are we going to expand this binomial expression a plus b to the power of n? Actually, if a plus b is just raised to the power of 2 or 3, you can just do the FOIL here. So you can just multiply a plus b to itself. Let's say a plus b squared, you can just expand this by multiplying a plus b times a plus b, or a plus b cubed, you can multiply a plus b to itself 3 times. So a plus b times a plus b plus times a plus b. And that would be easy. But what if the exponent is more than 3, or 3 to 100? So how are we going to expand that binomial expression? So we will use the binomial theorem in Pascal's triangle. So the first thing we do is to determine the first term a and the second term b. So the exponent of a would start from n and would end in 0. So from a to the n to a to 0. And then for b, the exponent of b will start from 0 to n. And now for the coefficients of the terms, we will use the Pascal triangle. So we will start with 1, and then 1, 1, and then 1. 1 plus 1 is 2, 1, and then 1. 1 plus 2 is 3, 3, 1, 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1, and so on. So notice here that the end is always equivalent to 1. And also the number, the second number in each of the rows determines the exponent of the binomial given. So in the first one, the second term is, there's nothing here, this is 0. And the first one, the second one, it's the second number is 1, so the exponent is 1. The third row, the second number is 2. So these are the coefficients for a binomial expression raised to the power of 2. This one is for cube, this one is for the fourth, and this one is for the fifth, and so on. So let's try solving some binomial expressions. Let's say we're given 1 plus 3y cubed. Alright, so this is in the form a plus b to the n, where a here is equal to 1 and b is equal to 3y, and then the exponent n is equal to 3. And again, the exponent of a is decreasing from n to 0, and the exponent of b is increasing from 0 to n. So that would be, since the exponent is 3, exponent here is 3, so it starts with 3, and then it ends with a to the 0. And then for b, the exponent starts at 0, and then it ends with b cubed. So let's replace our a with the actual value of a here, which is 1. So that would be 1 cube. It starts with 1 cube and it ends with 1 to the 0, which is just equivalent to 1, because any number raised to the power of 0 is equal to 1. And then b starts from 3y to the 0, which is also equal to 1. Then any number or terms or anything that is raised to 0 is equal to 1. And then it ends with b cubed, so 3y cubed, or this is 3 times 3 times 3, this is 27y cubed. And now for the coefficients, we use the binomial theorem. Since this is cube, so we start with 1. Let me use another color. Well, we start with 1, and then 1, 1, 1, 2, 1. So this is for exponent 0, 1, 2, and this one 1, 3, 3, 1. Since the exponent here is cube or 3, then we will use these coefficients. So our coefficient would be, okay, let me delete this. 1, 3, 3, 1. Okay, now let's expand 1 plus 3y cubed. So we start with 1, the coefficient, this one, 1 times a cubed, times 3y to the 0, plus the next coefficient, 3 times 1 squared, 3y to the 1, plus the next coefficient, which is 3 times 1 to the power of 1 times 3y squared, plus the last coefficient, 1 times 1 squared, no, 1, 0, because this is the last term, 3, 2, 1, 0, because a is decreasing and b should be increasing, 0, 1, 2, so 3y cubed. And now let's simplify the terms. All right, so 1 times 1 cube, 1 cube is 1, 1 times 1 is 1, times 3y to the 0. So anything that is raised to the power of 0 is equal to 1. So this is basically just 1 times 1 times 1, which is equal to 1, plus this one. 3 times 1 squared, 1 squared is 1, so 3 times 1 is equal to 1. And then 3y to the power of 1 is 3y. So this is just 3 times 3y is just equal to 9y. And then the third term is just 3 times 1 times 3y squared. So 3y raised to the power of 2 is just equivalent to 9y squared. So 3 times 9y squared is just 27y squared, plus the last term, 1 times 1 to the 0. So 1 to the 0 is equal to 1. 1 times 1 is 1, times 3y cubed. So 3y cubed is 3 cubed. That is 3 times 3 times 3. So this is 27y cubed. So this is our answer here. 1 plus 9y plus 27y squared plus 27y cubed. That means that this binomial expression y plus 3y cubed can be expanded into this one. Now let's try solving another problem. All right. So what if we're given this binomial expression y minus 3 cubed? All right. Let's determine our a. A here is equal to y. b is equal to negative 3, because our binomial expression is a plus b to the n, and n here, the exponent, is equal to 3. Again, since this is raised to the power of 3, that means from the Pascal's triangle, our coefficients would be 1, 3, 3, 1. Alright, so let's try expanding this. Take note that the exponent of a starts from n, then ends with 0, and then b starts from 0 and then to n. So that would mean, since our a is equal to y, so y would be raised to the power of n, then it ends with y to 0, and then our b is negative 3 raised to the power of, our n here is 3. From 3, then this one is from 0 to negative 3 cube. Alright, so let's start expanding this. You would only have 4 terms since our exponent is 3. So we start with coefficient 1. So 1 times a, which is y cubed times negative 3 to the 0 plus 3, the second coefficient, times y squared times negative 3 to the 1 plus 3, the third coefficient, times y to the 1 times negative 3 squared, and the last term with coefficient 1 times y to the 0 times negative 3 cube. And now let's simplify the terms. 1 times y cubed times negative 3 to the 0. So this is just equal to y cubed. And then 3 times y squared times negative 3 to the power of 1. 3 times negative 3 is negative 9 times y squared. This is negative 9y squared. And then 3 times y, which is 3y, times negative 3 squared is negative 3 times negative 3, which is equal to positive 9. And positive 9 times 3 is just 27. So this is positive 27y. And then 1 times y to the 0, which is equal to 1. So 1 times 1 is 1. And then negative 3 cubed. Negative 3 cubed is just equivalent to negative 3 times negative 3 times negative 3. So negative 3 times negative 3 is positive 9. And positive 9 times negative 3 is negative 27. So this is minus 27. So this is our answer here. Therefore, y minus 3 cubed can be expanded as 9 cubed minus 9y squared. Y cubed minus 9y squared plus 27y minus 27. Now let's try another one. Alright, what if we're given this binomial expression 2b plus 1 to the 4th? Okay, notice here the exponent is 4. So the value of a, okay, let's determine a first. A is equal to 2b and b is equal to 1 from the binomial expression a plus b to the n, and n, which is our exponent or power, is equal to 4. And again, the exponent of a starts from 4 and ends in 0, while the exponent of b starts from 0 and then ends with 4. So the exponent of a is decreasing, exponent of b is increasing. So take note of that. And now for the coefficient Pascal's triangle. So 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So we will use this row here where the second number is 4 because our exponent here is 4. Therefore, the coefficients of this binomial expression are 1, 4, 6, 4, 1. Alright, so let's expand 2b plus 1 to the fourth. So we start with the first coefficient, that is 1, and then our a is 2b, so 2b to the fourth, and then b to the 0, plus the second coefficient 4 times 2b cubed times 1 to the power of 1, plus the next coefficient 6 times 2b squared times 1 squared, and then plus 4 times 2b to the power of 1 times 1 cube, and then the last one, this one, the coefficient 1 times 2b to the 0 times 1 to the fourth. All right. Okay, let's check again if we did it right. A should be should be decreasing 4, 3, 2, 1, 0, and B is from 0, 1, 2, 3, 4. And now we can simplify each of the terms. So 1 times 2b to the fourth. 2 to the fourth is 2 times 2 times 2 times 2, that is 8 times 2, that is 16. So 16 b to the fourth, because 1 to the 0 is equal to 1, plus 4 times 2b cubed. 2b cubed is 8. This is 8b cubed. And 8 times 4 is 32 times 1. So this is 32b cubed, plus 6 times 2b squared, and 2b squared is just equal to 4b squared, and 1 squared is equal to 1. So 6 times 4 is 24 times 1, that is 24, then times b squared. So this would give us 24b squared. And then for the next term, this one, plus 4 times 2b is 8b times 1 cube is still 8b. So this is 8b. And the last term, plus 1 times 2b to the 0 is equal to 1. So 1 times 1 and 1 to the fourth is just 1. So this is plus 1. So this is our answer here. Therefore, 2b plus 1 to the fourth can be expanded into 16b to the fourth, 32b cubed plus 24b squared plus 8b plus 1. Now let's solve another problem wherein we need to find the nth term of a given binomial. All right. What is just the fourth term of 3c plus 4d to the seventh? Okay, our exponent here, n, okay, from a plus b to the n, our power exponent is equal to 7, a is equal to 3c, and then b is equal to 4d. Again, the exponent of a, which is 3c, okay, a should start from 7, so it should be 7, 3c raised to the power of 7, and ends with 3c to the 0, while whereas b starts from 0, or 4d to the power of 0, then it ends with 4d to the 7th. Okay, actually we don't need to expand this binomial expression up to the 7th term or the 8th term. We can only get the 4th term. So let's check for the coefficients of the fourth term using the Pascal's triangle. So there'll be 1, let me use another color, be 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, then 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. We will only need the fourth term. We are asked for the first term of the expansion of 3c plus 4d to the 7th. And these are the coefficients of the binomial expression. That would be 1, 7, 21, 35, 35, 21, 7, and 1. Okay, so we only need the fourth term, so we would stop up to here, the fourth coefficient. So now let's write the binomial expansion of 3c plus 4d to the 7th. So we start with the first coefficient 1. 1 times our a is 3c to the power of 7 times b, which is 4d to the power of 0, plus 7 times 3c to the power of 6 times 4d to the power of 1, plus 21 times 3c to the power of 5 times 4d squared, plus the next coefficient for the next term. The fourth term is 35 times 3c to the fourth times, that is 4d cubed. Alright, so we're only interested in this term, which is the fourth term. So we can only expand this one. We don't need to simplify the rest. So this would be 35 times 3c to the fourth. 3 to the fourth is equal to 81. So this is times 81 c to the fourth. And then 4d cubed. 4 cubed is equal to 64. So 64d cubed. And then we multiply 35 times 81 times 64. This would give us an answer that is equal to 181,440 c to the fourth d cubed. Alright, so the fourth term of the binomial expression 3c plus 4d raised to the power of 7 is equivalent to 181,440 c to the fourth d cubed. Now let's try solving another problem. What if we are asked for the coefficient of a certain term of a given binomial expression? Right. What is just the third coefficient of 3t plus 5m raised to the power of 8? Okay, again, let's determine our a and b. So a here is 3t, b is 5m, and n, our exponent, is equal to 8. Now we just need the third coefficient, meaning the coefficient of the third term. And now for our coefficients, it would be, since this is 8, we've previously determined the coefficients of the binomial expression raised to the power of 7. That's 1, 7, 21, 35, 35, 21, 7, 1. I don't need to write down everything. So since this is the seventh, for the exponent 7, then for exponent equal to 8, this would be 1, 8, 28, 56, 70, 56, 28, 8, 1, and so on. But we are only interested in the third term to get the third coefficient. Okay, so let's write down the terms up to the third term of 3t plus 5m to the 8. All right. So our coefficients are these ones, but we will stop until the coefficient 28. So this would be 1 times a, which is 3t raised to the power of 8, and b is 5m to the power of 0, plus 8 times 3t to the power of 7 times 5m to the power of 1, plus, okay, the third term with coefficient 28, 28 times 3t to the power of 6 times 5m squared. Okay, we don't need to expand the first and second terms, because we are only interested in the third term to get the third the coefficient. So let's expand this. 28 times 3t to the power of 6. So 3 to the power of 6 is just equal to 729. So this is 729 to t to the 6. And then 5m squared is 25m squared. And now we can multiply 28 times 729 times 25, and this is just equivalent to 510,300 t to the 6 m squared. Okay, so that is the third term, and we are asked for the coefficient. So the coefficient is 510,300. So this is the coefficient of the third term.